Hey everyone, and welcome back to the channel. Ever wondered how Python does math, like adding numbers together? Or how it can compare things, like checking if one number is bigger than another? It's all thanks to something called operators. Think of them as special symbols that tell Python to do a specific job, like adding, subtracting, or comparing. In this video, we're going to learn about two main types: arithmetic operators for doing calculations, and comparison operators for checking relationships between values. By the end of this lesson, you'll understand how to use these fundamental tools to perform math and make basic checks in your Python code. This is super important for writing useful programs. Ready to unlock these powerful building blocks? Let's dive in. All right, let's start with the theory. Don't worry, we'll keep it simple and quick before we jump into coding. First up, arithmetic operators. These are the symbols you use for mathematical operations. You probably know most of these. We have plus for addition, like 5 plus 3, minus for subtraction, like 10 minus 4, star for multiplication, like 6 times 7. Now, division is a little special in programming. Slash is for standard division. Notice how it always gives you a number with a decimal point, even if it's a whole number result. This is called a float in Python, and if it's not a clean division, you get the full decimal. Sometimes you only want the whole number part of the division. Double slash is for integer division. See? It just gives you the whole number part, ignoring the decimal. This is useful when you only care about how many times one number fits into another. What if you want the leftover amount after a division? 8% is the modulo operator. If you divide 10 by 3, you get 3 groups of 3 with 1 left over. Modulo gives you that 1. This is handy for things like checking if a number is even or odd. A number modulo 2 will be 0 if it's even. And finally, to raise a number to a power, double star is for exponentiation. This is like saying 2 to the power of 3, which is 2 times 2 times 2 equals 8. Just like in regular math, Python follows an order of operations. Think of PEMDAS or BODMAS. Parentheses go first. Great, that covers the math side. Now let's look at how Python compares things. These operators are used to compare values and check if a condition is true or false. Equals is for checking if two values are equal to. Is 5 equal to 5? Yes, so it gives us true. Is 5 equal to 6? No, so it gives us false. Pay close attention here. Double equals is for comparing if two things are equal. Single equals is for assigning a value to a variable. This is a very common mistake for beginners. Not equal is for checking if two values are not equal to. Is 5 not equal to 6? Yes, that's true. Is 5 not equal to 5? No, that's false. They're equal. Greater than is for greater than. Less than is for less than. Greater than or equal to is for greater than or equal to. Less than or equal to is for less than or equal to. The super important thing to remember about comparison operators is that their result always a Boolean value. It's either true or false. These true-false values are the basis for making decisions in our programs, which we'll see in the next video. All right, theory covered. Let's get our hands dirty with some actual coding. Open up your code editor and let's practice. Let's start with arithmetic operators. We'll use a couple of variables. Let's work with these numbers. Num1 equals 25, num2 equals 7. Arithmetic operations. Print arithmetic operations. Okay, first, simple addition. Sum result equals num1 plus num2. Print f sum result, using an f string to easily include the variable. There we go, 25 plus 7 is 32. Now subtraction, multiplication, and standard division. Difference equals num1 minus num2. Printf difference, product equals num1 times num2. Printf product. Division float equals num1 divided by num2. Standard division. Printf standard division float. See how the standard division gives us a float result? Now, integer division and modulo. Division integer equals num1 divided by num2. Integer division. Printf integer division, division integer. Remainder equals num1 modulo num2. Modulo. Print remainder, remainder. 25 divided by 7 is 3 with a remainder of 4. Perfect. And exponentiation. Let's do num2 to the power of 2. Power result equals num2 to the power of 2, 7 to the power of 2. Printf power 7 to the power of 2, power result. That works. Now, let's look at the order of operations. What do you think this will print? Order of operations example. Calc1 equals num1 plus num2 times 2. Printf calculation 1, num1 plus num2 times 2, calc1. Why 39? Because multiplication happens before addition. 7 times 2 is 14, plus 25 is 39. If we wanted the addition to happen first, we use parentheses. Cal2 equals num1 plus num2 times 2, parentheses first. Print calculation 2, num1 plus num2 times 2, calcs 2. Now we get 64 because 25 plus 7 is 32 and 32 times 2 is 64. So parentheses are important. Okay, let's move on to comparison operators. Remember, these give us true or false. Comparison operations. Print comparison operations. Add a blank line for clarity. Age equals 20. Is age equal to 20? Is exactly 20 equal age equals 20? Printf is age exactly 20? Is exactly 20? Yes, it is. So we get true. Is age not equal to 20? Is not 20 equal age not equals 20? Printf is age not 20? Is not 20? No, it is 20, so the result is false. Let's try greater than and less than. Is older than 18 equals age greater than 18? Print is age older than 18? Is older than 18? Is younger than 25 equals age less than 25? Printf is age younger than 25? Is younger than 25? Both are true for age 20. Now, greater, less than, or equal to. Can vote equal age greater than or equals 18? In many places, 18 is the voting age. Printf can age vote greater than or equals 18? Can vote. Gets junior discount equals age less than or equals 12. Example, junior discount age. Print gets junior discount less than or equals 12. Gets junior discount. Correct results based on age 20. Let's look at a common comparison mistake, comparing different data types. What do you think print 5 equals 5 will do? Common mistake, comparing different types. Print is 5 equal to the string 5, 5 equals 5. It prints false. Python is smart enough to know that the number 5 is not the same as the text 5. They are different types of data. Most of the time, trying to compare completely different types like a number and text won't work or will give you false because they aren't the same kind of thing. Another one, comparing numbers with decimals, comparing floats and integers. Print is 10 equal to 10, 0, 10 equals 10.0. This one is true. Python understands that the integer 10 and the float 10.0 represent the same value. This usually works fine for numbers. Finally, a quick look at comparing strings. Python compares strings letter by letter based on their order in the alphabet, or more accurately, their Unicode value. Comparing strings. Print f is apple less than banana, apple less than banana. Print f is apple less than apple, apple less than apple. Capital letters come before lowercase. This shows how string comparison works. Awesome. We've practiced arithmetic and comparison operators in isolation. Now let's see how they work together in a simple, practical example. Okay, time to put these operators to use in a mini project. We're going to write a small script to calculate the body mass index, BMI, and then use comparison operators to make a simple evaluation. BMI is calculated using a formula, weight in kilograms divided by height in meters squared. We'll need arithmetic operators for this. We'll also need to get input from the user. Remember the input function? It always gives us text, a string, so we need to convert that text into numbers. We'll use float for numbers with decimals. BMI calculator. Print BMI calculator. Get input from the user. Remember input gives strings, so we convert to float. Weight kg equal float input, enter your weight in kilograms. The height m equal float input, enter your height in meters. We ask for weight and height and immediately convert the input strings to floating point numbers so we can do math with them. Now, let's calculate the BMI using our operators. Calculate BMI, weight divided by height squared. BMI equals weight kg divided by height m to the power of 2. We use slash for division and to the power of for squaring the height. We put height m to the power of 2 in parentheses to make sure that calculation happens before the division, just like in the formula. Let's print the calculated BMI. Print the calculated BMI. Print f, your BMI is BMI. This part uses an f string again to show the result nicely. Let's try it. I'll put in some example values. Okay, it calculated the BMI. Now let's use comparison operators to make a simple check. Is this a healthy BMI according to a basic range? The typical healthy range is between 18.5 and 25, not including 25. We need to check two things. 1, is the BMI greater than or equal to 18.5? 2, is the BMI less than 25? We can combine these checks. For now, we'll just print the result of each comparison. In the next video, we'll learn how to use these results to make the program do different things. Use comparison operators to check if BMI is in a healthy range. 18.5 to less than 25. Is above min healthy equals BMI greater than or equals 18.5. Is below max healthy equals BMI less than 25. Print is BMI greater than or equals 18.5 is above min healthy. Print is BMI less than 25 is below max healthy. Combine them. Is healthy range equals is above min healthy and is below max healthy. Printf is BMI in healthy range, 18.5 to less than 25, is healthy range. We create two Boolean variables, one for each check. Then we print their results. Last line uses the AND keyword, which means both conditions must be true for the result to be true. Let's try those values again. See how we get true or false based on the calculated BMI. This is how we start to build logic in our programs. All the code snippets from this video, including this BMI calculator script, are available for you to download and play with. Check the video description below for the link. You'll also find a challenge, quiz, and other helpful resources there. You've done great learning about these basic operators. Now it's time for you to practice and reinforce what you've learned. Here's a simple coding challenge for you. Write a Python script that 1. Asks the user for the length of a rectangle. 2. Asks the user for the width of a rectangle. 3. Calculates the area of the rectangle, length times width. 4. Checks if the calculated area is greater than 100. 5. Prints the calculated area. 6. Prints true or false based on whether the area is greater than 100. This challenge uses both arithmetic for area and comparison for checking if it's greater than 100 operators, just like we practiced. Hint: remember to convert the user input from strings to numbers, probably using float since dimensions can have decimals. Pause the video, give it a try. The solution is also available in the resources link in the description if you get stuck or want to check your answer. If you're feeling ambitious and want to explore more, look into augmented assignment operators. Symbols like plus equal, add and assign, e.g. x plus equal 5 is same as equals x plus 5. They are just shortcuts, but are used very often. Also, bitwise operators, and, or, hat, etc., exist for working with the binary representation of numbers, but those are for more advanced topics. Wow, you've taken a big step today. Let's quickly recap what we learned. We learned about arithmetic operators for doing calculations in Python. We saw how slash division gives a float and double slash gives a whole number, integer. We covered comparison operators for checking relationships and conditions. Crucially, we learned that comparison operators always result in a Boolean value, true or false. We also briefly touched on the importance of the order of operations and using parentheses. These operators are the fundamental tools that allow our programs to perform calculations and, most importantly, make decisions based on conditions. And that's exactly what we'll be doing in our very next video. We'll use the true-false results from comparison operators to control the flow of our programs using conditional statements, like if, elif, and else. This is where your code starts getting really smart. Don't miss it. Remember to check the description for all the resources mentioned: code snippets, the challenge, a quiz to test your knowledge, and key takeaways. If you found this video helpful, please give it a thumbs up, share it with anyone learning Python, and definitely subscribe so you get notified when the next video on conditional statements comes out. Thanks so much for watching. Keep practicing, and I'll see you in the next video. Happy coding.